In this problem, we're being asked to complete the given table, comparing inequalities with words, math symbols, graphs, and interval notation. So let's look at the connection between these four different ways of looking at inequalities. The first example in our table here gives us the inequality in words. Tells us we're looking for numbers greater than or equal to -4. And that or equal to, we want to be sure that we pay attention to that part, that or equal to. So we know that greater than is this way. And when we see the or equal to, that means that we'll be dealing with the little half of an equal sign underneath that symbol. So when we start talking about the math inequality, we're going to be using the greater than or equal to sign. They're talking about numbers. Now, we don't know exactly what those numbers are. Those numbers can vary. So that's where we're going to bring in the variable. And we'll go ahead and just use the variable x. We could have used any variable we wanted to. And we're looking for all of those x values that are greater than or equal to -4. So this is the way we would write that as a math inequality, x greater than or equal to -4. Now on a graph, I already have my number line set up here. Notice I've got the arrows on either end. And since we're looking for numbers that are greater than or equal to -4, we're going to use the solid dot here on -4. And when we think of the numbers that are greater than -4, that means we're going to be looking for the numbers to the right. And so this is what our graph of that inequality would look like. Now, in terms of interval notation, we want to just look here at the number line to get our clue of where we start and where we end. When we look to the left, we say, well, how far does this thing go to the left? To the left, it goes to -4. And then when we say, well, how far does it go to the right? We're going to put a comma there. How far does it go to the right? Well, it goes forever to the right. And so when we talk about going to forever, mathematically, we talk about this symbol, this infinity symbol. It's like a sideways 8. So it's going to go all the way to infinity. So those are the numbers we want, but we also want to be careful of what symbols we use on the outsides of this interval notation. Because the -4 is actually included as a solution, -4 would make this inequality true. -4 is greater than or equal to -4. We're going to use a square bracket here that shows that that value is actually included. And whenever we work with infinity or negative infinity, it doesn't make sense to talk about including infinity because that's more of an idea. It's not really a number. So when we use infinity or negative infinity, we're always going to be using the parenthesis. The parenthesis indicates that we can go up to that, but it's not actually included. So that would be the completion of our first example. Now let's take a look at the second example. In the second example, we're given the graph and we have to fill in all the other parts of this. So when we take a look at the graph here, we can see that we start at 3 and we're going to the left of 3. So we know that we're talking about numbers that are less than 3. And also notice that it's an open circle on the 3. The open circle means that we aren't including 3 itself. So the part about or equal to would not be included. So in words, we would say that this is looking at the expression. Let me get this in here. I'm just going to type this in. This would be numbers less than 3. We wouldn't include the or equal to because the open circle is there on the 3. So now to look at our math inequality, we're still going to be talking about our numbers, our unknown numbers, x. Now we're saying that they're less than 3. So less than, here's our less than symbol. And remember that the arrow of the inequality symbol is going to be pointing the same direction as the arrow on our graph. And so that's a good way to help us to remember which way to go. So numbers less than 3, so that's saying that my numbers x are less than 3. Write that like that. And now as in the interval notation, again, we want to say how far to the left and how far to the right. How far we go to the left is going to be the first number in the interval, and how far we go to the right is always going to be the second number. So when we look at our graph, we say, how far does this thing go to the left? Well, this goes forever in the negative direction. It's going to go continue past 0 all the way down here to negative infinity. And so how far does it go to the left? It goes to negative infinity. How far does it go to the right? It goes all the way up to 3. So we want a comma between the negative infinity and the 3. And as we mentioned with our example up here, when I'm dealing with infinity or negative infinity, I'll always be dealing with the parenthesis. And here with this 3, because the 3 is not part of our solution, it has that open circle. It doesn't include the or equal to. And so we're going to use a parenthesis here as well. And so that's how we would write the interval notation for that problem.